All right, so the main important, so the most important thing is to have the inequality in slope-intercept form, where we can easily recognize the slope, which is this guy here, and then the y-intercept. So let's start with the y-intercept, which is 4. 1, 2, 3, 4. The slope is -3, so we know the line is going to look like this. So let me put the slope over here, -3. Let's put it over 1. So up and down, I want you to count 3. On left and right, I want you to count 1. So from here, I'm going to go 1, 2, 3, 1 to the right, because when I connect these dots, it has to come down. 1, 2, 3, because the slope is negative. There we go. This tells us that the line that we're going to use is going to be a solid line, right? Because points on that line are part of the solution, so that's why we use a solid line. There we go. I'll just bring this guy a little lower. And now we get to figure out if the coordinate points above the line or below the line are solutions to this inequality. So we take a test point, take 0, 0, right here, 0, 0. Let me change colors. Let me pick, and you can pick any other, right? You can pick this one or this one, or this one. You can pick any point you want, but 0, 0 is the easiest one. So let's replace in the inequality y was 0 and x was 0. So we got 0 greater or equal to -3 times 0 plus 4. 0 is greater or equal to -3 times 0 is 0, and plus 4 gives me 4. 0 is not greater to 4, so this point right here, 0, 0, fails, and it does not satisfy the inequality. And what does that mean? What that means is that any point on this side of our line, any point, will also fail. That's what it's telling you. So therefore, the solution, or the coordinate points that will satisfy this inequality, will be on this side. So you can pick any point on that side, and I'll pick, even though you don't have to, and this is our solution. So let me pick a point, just to prove it to you guys. Let's pick an easy point. Let's pick the point, this point right here. That point's 3, 1. If I plug in 3, 1 into inequality, I'm going to get 1 greater or equal to -3 times 3 plus 4. 1 greater or equal, -3 times 3 is -9, and if you add 4, you get -5. So is 1 greater or equal to -5? Yes, it is. So that point right here satisfies. So, and again, if you have time, pick a few more, plug it in, see if it's satisfied, just to, so that you are confident that the region here where you selected is the region that satisfies, where the coordinate points are located that satisfy this inequality. Second question. Again, the slope is 3 over 5. Y-intercept is -5, so let's go to -5, which is right here. Up and down, once you count 3, 1, 2, 3, and left and right, you're going to count 5. 1, 2, 3, 4, 5. There is no room in this particular coordinate plane for more than that. If we had a bigger one, you could plot more points, but this is enough. And this is, again, solid. So let's pick a solid line. And there we go. And this line has a name, which is y is less or equal to 3/5 x minus 5. We're going to pick the point 0, 0 again, right? And then substitute, so we get 0 less or equal than 3/5 times 0 minus 5. 0 is less than -5. Is 0 less than -5? No, it's not. So this point again, 0, 0, does not satisfy this inequality, which means these points here will also fail. So we don't want this side. We actually want this side. So points on this side of the line, including points on the line, will satisfy the inequality. Okay, and then let me put a big S. There you go. That's it. That's really simple. So what we do tomorrow is that we're going to graph 2 inequalities at the same time. Okay, and that's the only difference. Clear page. This one. Let me put a 1 here. So actually, let me rewrite that. Y is greater than -1x minus 5. I mean, you don't have to put the -1, but I put it just so that you recognize the slope. So the slope is -1, and it's over 1. So up and down, you're going to count 1, left and right. Right change in y is 1, change in x is 1. And it's negative, so from -5, which is here, right, it's a slope that goes down. So it's 1 down, 1 to the right, right, or 1 up, 1 to the left. And these are the points. Remember, it's negative, right? So the line has to go down. And this one, it's just a greater than sign. So the line, it's going to be a dashed line. So I'm going to use a dashed line. There we go. Give it a name, give it arrows. Y is greater than -x minus 5. And we're going to shade either So either it's points above the line or below the line that's going to satisfy this inequality. So let's take a test point. Again, 0, 0. Let's replace 0 and x, sorry, y and x with 0. So we get 0 greater than negative 0 minus 5. And 0 is greater than negative 5. Is 0 greater than negative 5? Yes, it is. So that tells you that this point here satisfies this inequality. So that means that points above our line will also satisfy. So to represent that, we just go like this. Okay. Y equals negative is greater than negative 4. So this one's where the slope is 0. Therefore, the line is going to be horizontal. So go negative 4, which is right here. And it's just a greater than sign, so it's going to be a dashed line. So I'm going to put it right over here. And give it a name. So now we want y values that are greater than negative 4. Well, if you look at your y-axis, the y values that are greater than negative 4 obviously are above the line. So we're going to do a test point. So again, if you take this test point 0, 0, here's your inequality, and we place 0 with y. 0 for y. Is 0 greater than negative 4? Yes, it is. So that tells you that this point, along with every single point above the line, will also satisfy the inequality. So we're not going to represent it like that, but we'd rather do this, right? So points that are not on the line and above the line make this inequality true. And if you want to put a big S here, there you go. That's your solution area. Okay. Clear the page. 5. So these are relatively simple, right? Everything is in slope-intercept form, so we can easily recognize the slope and the y-intercept. So again, here's the y-intercept, negative 5. Our slope is 2, and let's put it over 1. So changing y is 2, changing x is 1. So 2 up, 1 to the right, 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 and so forth. The inequality sign is just a greater than sign, so we're going to use a dashed line. Where is it? Here we go. Just like that. So y is greater than 2x minus 5. Pick the test point 0, 0. Let's see if 0, 0 makes this inequality true. So we replace, so the point 0, 0. Now replace x and y with 0. So 0 is greater than 2 times 0 minus 5. 0 is greater than negative 5. Is 0 greater than negative 5? Yes, it is. So this point 0, 0 made that inequality true. That also tells us that these points will also make that inequality true. So how do we represent that? We go like this. Okay. And here's a big S. That's the solution area. And then again, if that was a quiz, you would probably gonna be asked to pick a point. You would pick any point. Let me pick one right off the bat. 3 and 3. Let me pick the point 3 and 3. And then you would ask to replace it and see if it actually works. So if you take the point 3 and 3 and you replace it, you will get 3 greater than 2 times 3 minus 5. 3 is greater than 6 minus 5. And 3 is greater than 6 minus 5, which is 1, which again is a true statement. 3 is greater than 1. So again, a point above the line, not including the line, makes that inequality true. Last one. Y is greater or equal than 7 over 4x plus 2. Our y-intercept is 2. Our slope is 7 over 4, so let's count 7. And then we're going to count 1, 2, 3, 4, 5, 6, 7. We have to go 1, 2, 3, 4 to the left 4. Let's connect these dots. Here's my line. Y is greater, oops, sorry, made a mistake. Not a dashed line, a solid line because it's greater than or equal. So we use this line right here. Y is greater than 2x, sorry, y is greater or equal than 7 over 4x plus 2. Let's try 0, 0, see if 0, 0 makes that inequality true. So here's my 0, 0. We're going to replace the x with 0 and the y with 0. We get 0 greater or equal than 7 over 4 times 0 plus 2. 0 is greater than or equal than 2. Is 0 greater or equal than 2? It's not. So this point here, 0, 0, failed to make that inequality true. So guess what? This point's going to fail, this point's going to fail, this point's going to fail, this going to fail. And any point on this side or under the line is going to fail. So we don't want that. We want points on this side. And that's our solution. So any point on this side of the line, including points on the line, would make that inequality true. All right, so that was it. Oh, for the other class, let me just clear this. All right, so for some of you, you actually had this one, okay? And again, but this one's a little different. The difference here was that they were not in slope-intercept form, so you have to rearrange the equation in terms of y. Let's do that. It's not that many. So we're going to do minus 2x minus 2x. The x's go away. We get negative y less or equal to negative x plus 4. We're going to divide everybody by negative 1, right? Because we want the y positive. There's a 1 there. So negative divided by negative is a positive. I get this. Because I divided by a negative number, I'm going to switch the inequality sign. Negative divided by negative is a positive, so that's 2x. And then positive 4 divided by negative 1 is negative 1. Here's my slope. Let me put it 2 over 1. And here's my y-intercept, negative 4. So negative 4 is here. It's a positive slope, so it's going to go up. It's going to go 2 up, 1 to the right, 2 up, 1 to the right, 2 up, 1 to the right. It's going to be a solid line. Where's my solid line? It's going to be a solid line. There. All right, so let's get this line a name. Y is greater or equal to 2x minus 4. We're going to select 0, 0, see if it works. So we get 0 less greater or equal to 2 times 0 minus 4. 0 is greater or equal to negative 4. Is 0 greater or equal to negative 4? Yes, it is. So that means this point here satisfied inequality, which means every point on this side, the region that is to the left of the line, will also work. So all these points, any coordinate points on this side, will also work. Okay. You guys can work out the bottoms. So in class, I told you to change this to clear page. So it should be negative 3x plus 2y greater than 6 plus 3x on both sides. That goes away. We end up with 2y is greater than 3x plus 6. Divide everybody by 2, positive 2. We get y greater than 3 over 2x plus 3. Now you can easily tell who the y-intercept is, which is 3. The slope is 3 over 2. 1, 2, 3. 2 to the right. 1, 2, 3. 2 to the 1 to the right. It's a dashed line because it doesn't have an equal sign under. Here's my line. Now we have to shade either above that line or below the line. Take the point 0, 0, see if it works. If you take the point 0, 0, replace x and y with 0. So we get 0 greater or equal than 3 over 2 times 0 is 3. 0 is greater than 3. Is 0 greater than 3? No. No, it's not. No. So that means that this point failed to satisfy that inequality, and therefore this point will fail, this point will fail. Any point that's on this side of the world will also fail. So we don't want those points. We want the points on this side. Right? So if you took one of those points, and I'll take a moment here to show you, and let's pick an easy point. So let's take the point -1 and +5, which is right here. Right? So that points on the region where we selected and said that it's going to satisfy the inequality. Well, let's see if it's true. Here's my inequality. So the y is going to be equal to 5. 3 over 2 times -1 plus 3. And 5 is greater than 3 over 2 is the same thing as 1.5, right? So that's -1.5 plus 3, which is -1.5 or -1.5. Is 5 greater than that? Sorry, positive. Is 5 greater than that? Yes, it is. So again, prove to you that a point on that side of the line, that our slope makes that inequality true. The page, y is greater than 5. This one's easy. The y-intercept is 5 right here. The slope is 0, right? So when the slope is 0, we know it's a horizontal line, and we just got to decide if it's dashed or solid, and it's solid. Sorry, dashed. Oops, sorry. Dashed. And we want the area where the y value is greater than 5. Oops, I did this whole thing incorrectly. First of all, it's not negative 5, it's 5, so 5 is right here. It is a dashed line, and there we go. So we want the region where the y value is going to be greater than 5. So again, if you pick 0, 0, right, you pick the point 0, 0, and you replace, in this case, just a y, you're going to get 0 greater than 5. 0 greater than 5? No. So that means that this point here fails. So we don't want this area. That's not the area you want. But rather, we want the area on the top. Anything above that, y value is going to be greater than 5, not including the points on the line. Okay? And you guys can do everything else. Last one here. It's an error check here, so let's see what this gentleman or lady did on the page. So the first thing he did was switch these two, right? So put the 8y there and took these two guys and put on the side. You can do that, but when you do that, you have to change the inequality sign, which he did, right? 8y went to the left, 5 plus 6x went to the right. He changed the inequality from less than to greater than, perfect, and then he divided everybody by 8. Oh, and here's the mistake. When he simplified 6 over 8, 6 over 8 is not 1 over 2, it's actually 3/4. All right, so let's do it correctly here. So step 1, let me write this. 5 plus 6x less or equal to 8y. Switch sides, you get 8y, and on the other side. So if you switch these guys, right, switch sides, you have to change the inequality side. So we get 6x plus 5. So he did that correctly, and then he divided everybody by 8, which he also did correctly, but he simplified it correctly. So y is greater than should be 3/4 x plus 5, right? Let's graph this. So when we graph this, this one's going to be a little weird because it's going to be 5 over 8 right here, a little bit more than half. So as best as you can, the slope is 3/4, which means change in y is 3, and change in x is 4. So let's count 3. 1. Let's see how we do that. No. Okay, so 0.6, so 1 here. That's going to be tough. So here's what I'm going to do. So if you divide 5 over 8, okay, and change it to a decimal, it becomes 0.625. Right? So 0 is a little bit more than half. And then you're going to count 1 unit up. We're going to count actually 3 units up. So if you add 1 plus 1, you get 1.6. And then you get this. So we can count 1, 2, and then 1 more, 3. And then from here, we're going to go 4 right. 1, 2, 3, 4. And there's our 2 points. This one and this one. It is a solid line. And we get, let's call it, give it a name. Y is greater than or equal to 3/4 x plus 5/8. Let's use the point 0, 0, see if it works. If we do that, we get 0 is greater or equal than 3/4 times 0 plus 5 over 8. And 0 is greater or equal to 5 over 8. Is that true? No, it's not. That means 0, 0 failed, and everybody who is on the same side just points under the line will also fail, so we want these guys here. Any point above the line, including points on the line, will make this inequality true. And you can always pick one and try, or pick several and try. Okay, that's it, I think. Yeah, you guys can figure out.